Hello everyone, welcome to a data-driven exploration of nocturnal foraging behavior. Imagine a world where that actively data, fast foragers, race for food, and game gatherers compete for limited resources in the dark. Our team, Sydney Group 31, with team member Asin Sarma, August Resta, Sudham Singh, and me, Rosina Kuriti, head out to decode this dramatic interaction using over more than 700 recorded events, documented in a dedicated dataset provided by geologists. The core question we address is can we predict the foraging behavior based on time, season, and presence of stress? Listening to next slide. On-scene drama of the night. In this high-stakes nocturnal environment, every action involves a delicate balance between risk and reward. The forgivers adopt different strategies. Some play it safe and fit quickly, while others take bigger risks by confronting competitors like rats. Our mission is to use data science to make sense of these patterns, bringing to light drama that unfolds unseen in the darkness. Looking to next slide. Analytical mission object can approach. The project official objective is to analyze patterns in the behavioral dataset, but we have explained this into several clear analytical goals, like temporal patterns, risks and reward, seasonal shifts, all our analysis to use Python for data wrangling, exploration, and statistical testing. Let's move to the next slide. Raw materials. Our study draws on more than 700 nocturnal events that are all documented. The dataset covers multiple variables, including habit, risk, and reward, hours after sunset and sun season. One challenge is the presence of amnesia or missing data requiring careful filtering and data wrangling prior to analysis.
Thank you, team, for the intro. Before diving into the results, let me explain how we unlock the patterns hidden in our data and about our projects. We begin with two datasets that capture natural activities, risks, reward, and contextual factors like season, rat arrivals, and bat landings. Our goal was to uncover hidden patterns in natural activities to understand how risk-taking, reward, and seasonal changes interact in shaping behavior. To analyze this, we used Python along with libraries such as Pandas for data handling, Seaburn and Matplotlib for visualization, and SciPy for statistical testing. We explored the data descriptively, compared behaviors using plots, and applied chi-square tests to check whether differences, such as between risk and reward or between seasons, were statistically significant. This combination of exploratory analysis and statistical testing allowed us to move beyond raw numbers and really see the behavioral strategies emerging in the data. Here we see the frequency of different nocturnal behaviors. The most common is fast foraging, followed by rat-related events. This suggests that while low-risk strategies dominate, high-risk predators events are also significant. Looking at timing, most activity happen 2 to 4 hours after sunset with a lull around 6 to 8 hours. There is a small uptick before dawn, possibly linked to predator prey cycle. Breaking it down by behavior, fast peaks earlier in the night, rat peaks later while peak remain relatively steady. This shows different strategy. Some are quick and safe, others are riskier but delayed. Here we quantify the trade-offs. Rat events are nearly 100% risky, while fast and peak trend to be rewarding. Statistical testing confirmed a strong link between habit type and reward probability. When comparing seasons, we see higher rat activity in summer and more fast activity in autumn. This suggests that foraging strategy adapts depending on environmental condition. Overall, our analysis shows that nocturnal activity is not random. It is shaped by a clear hierarchy of behaviors influenced by risks and reward trade-offs and further adapted by seasonal conditions. These patterns highlight how animals balance safety and opportunity in a changing environment. Now for the further explanation, I would let my friend to carry on this presentation. Thank you.
So before I move on to my presentation, let's see whether the Python code runs or not. All right, we can see the changes. Now we can also know that the code has successfully run.
Yeah, so first of all, I want to thank my friend for handing me rest of the slide. So without wasting any time, let's get into it. So the first topic of my slide is, are the seasonal differences real? The main question after seeing seasonal changes was whether they were just random or actually meaningful. To test this, we used the chi-square test of independence. The results showed a p-value less than 0.001, which is extremely significant. From my perspective, this proves that the behaviors we see are not by chance. Animals are truly adapting based on the season. Moving on to the next slide, which is, what does a win look like? Next, we try to define what success and failure really mean in this context. We created an outcome column where success meant getting a reward, failure meant encountering risk, and neutral meant neither outcome. The violent plot makes it clear that timing plays a big role as well. Certain hours after sunset are linked with more success, while others lead to higher failure rates. From my POV, this shows survival isn't only about what choice an animal makes, but also about when they make it. Moving on to the next slide, which is the mystery in the data. This slide highlights the messy side of real-world data. Many rows in the dataset had missing values or strange number strings that didn't fit the behavioral patterns we were studying. We think these might actually be bounding box coordinates, which could open up opportunities for spatial analysis in the future. But for this project, we had to exclude them from the core behavioral analysis. Moving on to the next slide, which is the story that this data tells. Here, everything comes together into a clear narrative. The data shows that the activity peaks 2 to 4 hours after the sunset, that high rivers often come with risks, and that behaviors change significantly across the seasons. Another key is that success is strongly tied to timing. Yeah, and my last slide is going to be about decoding the night. Finally, this slide shows the bigger picture of our approach. We apply data science techniques to transform raw, unorganized information into insights about why and when certain behaviors happen. To me, this mirrors a real-world workflow. We started with a question, cleaned and analyzed the data, and built a story that makes sense all of it. From my point of view, the most rewarding part is seeing how data can help us decode something as mysterious as nocturnal life. Thank you.
Thank you, my friend Orchid, for your presentation. Now I'm going to start my presentation from slide 15. And the next topic is our responsible analysis. We also consider limitations in ethics. The dataset lacks species or location metadata, which restricted the scope of our conclusions. But we ensure responsible use of wildlife data. AI tools are used only to assist with debugging code and improving visualizations. All interpretations of results are our own. And moving on to the next topic is where could this go next? Looking ahead, there are exciting opportunities to expand this work. First, we could use the bounding box coordinates for spatial analysis, mapping behavior across space. Second, we could build predictive models for forecast outcomes like success or failure. And the third, sequence analysis methods such as Markov chains could help us to understand how one behavior transitions into another during night. Moving on to the next topic. The next topic is explore the night in action. We also experimented with interactive visualizations. This allows users to filter the data by seasons or risk level and explore hidden patterns themselves. This hands-on engagement makes the findings more intuitive, opens a door more public or scientific exploration. Moving on to the next topic. The next topic is next step in nocturnal research. The next step in nocturnal research could include predictive modeling for forecasting success, integrating spatial mapping of events, and expanding the dataset to cover more species or different locations. This would create broader and more powerful ecological picture. Moving on to the next topic is our code and data. Finally, our code and clean dataset are available on GitHub, along with this presentation also. We welcome feedback on both our code and analysis. And the last but not least, we would like to acknowledge our references. Proper citation is important, and we want to give credit to the original researchers and who collected the shared this valuable data. Thank you very much for your attention.